Okay, good evening. Let me just test, let me unmute you to test whether you can be able to get me. Good evening.
Hi, good evening.
Are you able to get me?
Yes.
All right, okay, fine.
We're here. We're here.
Okay, that's great. Okay. Okay, so last time we started looking at module 6, Ethernet and IP protocol. Okay, we looked at this already. So you see here, unlike wireless, this is when we are able to send, information via the waves. So unlike wireless, Ethernet uses wired communication, okay? And the types that we have for wired communication are twisted pair, okay? Fiber optic. Fiber optic is the one which uses flashes of light to move information from one point to the other, okay? And then twisted pair uses magnetic pulses. And then the coaxial cable, that's the one, we use in our DSTV. Okay, so this Ethernet, it works at 2 layers, you see, physical layer and data link layer. And by the way, this is the OSI model, the model which makes it easy for us to operate and learn networking, okay? All right, so if you see here, this is Ethernet, okay? And when you look at the data link layer, it is divided into 2 sub-layers, the logical link control and the media access control, okay? Why? Because it is this layer which prepares information to be put on different media, okay? All right, so we looked at this. We also looked at the Ethernet frame structure, okay? So this is the Ethernet frame structure, which has the preamble. You see, what else? Destination MAC, source MAC. For anything to move over a network, it must have addresses. So since we are talking about Ethernet or a local area network, the devices in a local area network, for example, in my room here, if I connect 3 computers, I've created a local area network. The computers in my office will be communicating using the frame. That's why you can see here, destination, address, source address, okay? The type or the length. This part deals with what will be the next protocol that we'll be dealing with. Mind you, we have the physical layer, data link layer. What is the next layer? Network layer. So which protocol are we going to be dealing with? So that one covers, data type, length and type. And then we have data, which is the actual data which has to be moved. And then we have the frame check sequence, which is used to check for errors in the frame. Okay, so we did all this. And then now the MAC address or the physical address. So you find that your laptop has the physical address, okay, or a MAC address, which is unique, okay? Now, this MAC address, you can see here, has 48 bits, okay? The first 24 bits are used to identify the manufacturer of that device, okay? So just by looking at the first 24 bits, you can be able to tell that this laptop belongs to Dell. Then the last 24 bits, they are used to distinguish now the devices made by Dell, okay, and so on. And we have 3 ways in which this MAC address can be represented in form of dashes, colons, or just periods. Okay. All right. IPv4. So IP version 4. Okay. Just a minute. Anyway, sorry for that. We're dealing with IP version 4. Okay, so you see, we are moving upwards, okay? From Ethernet, we're moving upwards. From dealing with the frame, we are now be dealing with the packets, okay? So this is the network layer. So here, you can see we have IPv4 and IPv6. Okay, so mainly the function of the network layer is to allow devices to exchange information across the network or across the internet. That is the job of this network layer. Okay, so apart from having IPv4 and IPv6, we also have dynamic routing protocols. Okay, for example, OSPF. Now, the internet, what you see there are just routers which have been connected. And these routers, they share the information about what they know, the routes, the paths. And how do they do that? They do that by using what are known as dynamic routing protocols. So for example, OSPF is one of them, okay? And then ICMP, this is just used for, you know, diagnosing the network and so on. Okay, so what are some of the basic operations of a network layer protocol? Okay, so you can see addressing end devices, what addressing, IPv4 addresses and IPv6 addresses. Okay, the other thing is encapsulation. Okay, encapsulation has got to do with you know, adding the network header. You know, so you see when information is coming down here, okay, when it reaches the network layer, the network header will be added to that information. And what do we have in the header? What we have in the header are the IP addresses. Okay, and then routing. So the routers, their job is to calculate the best path and also direct packets towards their destination. Okay, so this layer, you see, when we are moving down, we are adding the headers. That process is called encapsulation. Now, when we reach the other end, when the device has received information, okay, we'll start moving up. And when we start moving up, we have to remove the headers. So when we reach here, we're going to remove the header, and that process of removing the header is called decapsulation. Okay, that's how things work. Okay, so here you can see there's this animation, you know, even in your book where you can play it and see how, you know, what's happening. Okay, so we have messages moving from this PC to this laptop. Okay, it has to go down when it's coming, and then it has to pass through the internet. You can see the internet normally is represented as a cloud, but really what is there are routers. So the routers are the ones which are going to direct the traffic to the laptop. Okay, so when we are here, remember I told you that in a local area network, we use MAC addresses, but on the internet, we have to use IP addresses. Okay. All right, so I have talked about IP encapsulation. So this is what we get from the transport layer. Of course, when data is coming down, it is just data. Okay, when it reaches the transport layer, we're going to add the transport header to data, and this PDU will be called a segment. So this same PDU, when it reaches the network layer, we're going to add the IP header. Okay, so this process of adding the IP header is what is called encapsulation. Okay, all right. I think we looked at that also. What are some of the characteristics of the IP? I think I talked about this. The characteristics of an IP are connectionless, meaning that when I've got two PCs which are communicating, the IP address does not establish any connection. So in this case, another protocol, which is the TCP, is the one which is going to establish the connection. Okay. And then it uses best effort, meaning that when we're sending IP, we don't we don't expect to receive acknowledgements. Okay, that is done by TCP. The other characteristic is media independent, meaning an IP can move over copper medium, fiber optic medium, or wireless medium. Okay, all right. So okay, so this is an analogy of connectionless. When you receive a letter, sometimes you just receive the letter. You're not being informed. So that's how IP works. Okay. All right. Best effort. Here, best effort, it means unreliable. Meaning, when we send the packet, we do not receive any acknowledgement that the packet has been received. That work is done by the TCP, protocol. Okay, so this is what we call best delivery. Okay, and this is what we call media independent. So the IP can be able to pass through copper Ethernet, copper serial, optic fiber, okay, copper Ethernet, as well as wireless. You know, it passes through any media independent. Okay, so now the IP has the IP header, okay, the IP header. So this is one of the primary network layer communication protocols, okay? So the header is used to ensure that this packet is delivered to its next stop on its way to its destination, okay? Now, we are going to see these components which the IP header has. And these components that you see here, they are in form of numbers. So we're going to use the Wireshark to open up the packet and see. Also, for cybersecurity analysts, you must be familiar with each and every component of this header, okay? Because what hackers do is to alter these and use them for malicious purposes. So we have the version here. So this talks about what version is this? Is this IPv4 or not? Or IPv6? Okay. So when we have 100 here, it means that we're dealing with the IPv4 header. Okay. Then we have the internet header length. Okay. So the total length of the header. And then we have the DS. Okay. So this part is for prioritizing traffic. So you see, certain traffic on a network needs to have a higher priority as compared to others. For example, the traffic that we use on IPv phones, it has to be given a higher priority as compared to email traffic and so on. Okay, total length, the total length of the header, and then we have got these three parts here: identification, flag, fragment, offset. Okay, how are these used? All right, you find that sometimes when a packet is moving on certain networks, it is required that we use a packet which has got a smaller size. So that packet is going to be fragmented. Okay. Now, on the other end, these three parts are responsible of identifying those chunks and reassembling them. Okay, that's how it works. And then time to live. We have this because, sometimes anything can happen to a packet whereby a packet does not know where to go. In that case, a packet can move perpetually, over the internet. The reason for TTL is that, this is a value given to a packet, a fixed value. So when the packet moves from one router to the other, the value decreases. Okay. When the TTL value reaches 0, that packet is dropped. Okay. So we have the protocol here, the head checksum for errors. This is the source IP address. And of course, we must have the destination IP address. Okay. All right. IP addressing basics. Okay. So the IPv4 has 32 bits. Okay. So this is the IPv4 address. It has two sections. It has the network portion and it has the host portion. The network portion is used to identify where this network belongs. And the host portion is used to distinguish the hosts. Okay. And what you must know is that these numbers are in ones and zeros. That's how the computer understands them. But it is difficult for us to work with ones and zeros. Therefore, we change them into decimal. Okay? How to change these into decimal? You use what is known as a binary chart. okay? We use what is known as a binary chart, right? So the binary chart, of course, it starts as, 2 to the power 0, which is 1, 2 to the power 2, 2 to the power 3, and so on, okay? So what we have here is going to be 64. This one is going to be 32. When you add these, you get what? 1 and 2. So that's how you change. That's how you change from binary to decimal. So you have to use a binary chart, which starts as 2 to the power 0, 2 to the power 1, and so on, 8 of them, okay? All right, the subnet mask. Okay, so I think you have seen this. You see your laptop can get the IP addresses either automatically used through the use of DHCP or manually, okay, statically. That is, you key in manually. So you can see this is the IP address. And then it is followed by the subnet mask. Okay. Why do we need the subnet mask? Okay. The subnet mask helps us to know to which network we belong. Okay. We're going to see that. And have you seen this? This is the default gateway. Okay. So this is the IP address that we use to move from our network to the other network. Okay. All right. So, so this is the IP address, okay? And this is the subnet mask, okay? So what you do is you change these into 1s and 0s. And then you change these into 1s and 0s. Then the process that we're going to use is called ANDing. Okay, so what is ANDing? Let me just, okay, so ANDing, let's say 1 and 1, it always gives us 1, okay? 1 and 1, it also gives us 1. 0 with anything, it always gives us 0, okay? That is what's called logical AND, okay? So when we do the ANDing here, what we're going to get in the end is the network, okay? The network where the computer belongs, okay? Let me see if there's any, okay, there isn't. Okay, so if you can see, we have 192.168.10.10. This is an IP address. But when we do the ANDing, here we're going to get 0. So 192.168.10.0 is called a network, okay? So when you combine the subnet mask plus the IP address, that gives us a network, okay? So the subnet mask that you saw can either be represented as, for example, 192.168.10.10, 255.255.255.0. It can be represented like this. Or it is represented as 192.168.10.10/24. Okay, so this is another way of representing the subnet mask. Now, where did they get this 24 from? Okay, where you get the 24 from is from here. So you have to change this from decimal to binary. So when we change 255 to binary, we're going to get 8 ones here. So 8 ones plus 8 ones plus 8 ones, that is what? 24, okay? That's how it's done. Okay. All right, so from here, this is what I was telling you. Okay, so this is 255. When you change it into binary, it will be like this. So this subnet mask can also be written as slash what? 8. You just have to count these ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 255 to 255. So you change this to binary. Okay, it will give us 8 ones. So 8 plus 8, that's how you can see, slash 16, and so on. Okay. Now, this is the logical ANDing I was telling you. 1 and 1 will always give us 1. 0 and 1, it will always give us 0, and so on. Okay. Now, I've explained about this already. So we have the IP, which we have to change into 1s and 0s. Okay, we have the subnet mask, which we have to change into 1s and 0s. Okay, so here you can see 1 and 1, it's 1. 1 and 1, it's what? It's 1. Okay, so once we have this, okay, once we have this, we can also change this back into decimal for us to get the network address, okay? All right. So as you can see, in the end, the network address we're going to get is going to be this. So what do you do? Here, as I've told you, you have to use a binary chart for you to change this binary into decimal, okay? And I've told you that that binary chart goes as 2 to the power 0, 2 to the power 1, up to 2 to the power 7, okay? So you see, the goodness with our materials is that there's this video which you have to watch if you didn't get if you didn't get it. Okay, all right. So you have this organization, okay, and in this organization you have got so many switches, okay, and when you have so many switches, it means that when the broadcast reaches this switch, it has to go to all the switches. And those broadcasts do consume bandwidth, hence they make the operational network to be slower, okay? So how do you overcome such a problem? You can divide your network into 2 networks by using a router. Have you seen? So what the router does is it blocks the broadcasts. Okay, so here what I have is a single broadcast domain. Okay, so a broadcast domain is how far the broadcast is going to reach. So the broadcast is going to reach all this network. Okay, but in this case, I have created 2 broadcast domains. Okay, the broadcast cannot move over the router. Once the router receives the broadcast, it drops that broadcast. Okay. All right, so that's how it's done. Okay, so what are some of the types of IPv4 addresses that are there? Okay, so we have address classes where we can divide the addresses into classes. So you can see class A is starting from 0, okay, up to 227, okay. Class B, 128 up to 191. Class C, 192 up to 223, okay. Then we have class D, which is used for mount casting, and then E is used for experiments. Okay, so you see, you can see that about 50% of the addresses when using classes belong to class A. So this wasn't good at all because it used to waste some addresses, okay? Other types of addresses that are there are known as private addresses. So private addresses are addresses that can be used by a number of organizations. So you see, with IPv4, since we have got 32 bits, that gives us at least 4 billion addresses. But the internet, has been expanding, so we are running out of those addresses. Therefore, they decided to come up with what is known as NAT, Network Address Translation. And under NAT, they came up with the private addresses. So these are addresses which can be used by so many organizations. But the thing is, a PC with a private address, it cannot communicate to the internet. For it to do that, it has to be NATed. It has to be given a public address. So you can see these are the ranges of private addresses, okay? Make sure that you know these ranges, okay? So you can see here that, here in this network, we are using private addresses. So this PC, it will be blocked, okay? What do? We can configure what is known as NAT, whereby we are going to have what we call a pool of public address, so that when this guy wants to go to the internet, he goes to the pool, he picks an address, and he goes to the internet, okay? All right. The default gateway, okay. So here is our network, as you can see, okay? This is our local area network. Now, the default gateway of this network here is this interface of the router, okay? So you can see this is the network, okay? 192.168.10.0. And then this has an IP address as 192.168.10.1. So this is the default gateway for the switch, for this PC, and for this PC, okay? For this server, anyway, I think it's sitting on the internet, so we can't tell clearly, okay? So the devices use the default gateway to move. You see, if this PC wants to go to the internet, it has to use this gateway, okay, to go to the internet. Okay. All right. I think I've covered most of this stuff. If you, the thing is also, there is a table on your PC where routing information is being kept. If you want to see that information, you can just go to the command prompt and you type route print, okay, or netstart -r command, okay. Very, very important that you know these commands, okay. So this is the table that you can see on your laptop, okay. Just have to type in that command there, okay. So since we're running out of IPv4, they introduced IPv6, okay? You can see that it has 128 bits. So this one gives us trillions and trillions of addresses, okay? And in each continent, you can see these are the organizations responsible of assigning IP addresses in making sure that there is order on the internet, okay? We are running out of 4 addresses because of, the internet is evolving. We now have, the Internet of Things, okay? We have so many computers now, tablets, smartphones, and so on. All those, they need an IP, a unique IP address. Okay, so here, this is the format, very long. So this, as you can see, this is hexadecimal numbering system, which starts from 0 up to 9, then A, B, up to E. So this is what we have here. And when we expand it further, it means on this single X, we have 16 bits, okay? So this is called a segment, okay? All right, now, you can see that this is IPv6. It's very long, okay? So to shorten these addresses, they came up with 2 ideas. The first idea or rule is omitting leading zeros, meaning here we're going to remove this 0. Just remain with 1 AB, okay? Removing reading zeros, okay? Then the other rule is double colon, where you have consecutive zeros, okay? So, and you must have only a single double colon in an address, okay? So you can see here, these consecutive zeros will be replaced with a what? A double colon, okay? So you can see, let us look at this address. The first rule, remove reading what? Zeros. We remove reading zeros, okay? We have done that. The second rule will be now removing repressing the consecutive zeros with double colon, okay? So you can see these will be replaced with double colons, okay? So we have this, and we're going to end up with this address, okay? So that's how it works, okay? And then the IPv6 has got 2 parts called the prefix and the interface ID. Remember, when we looked at the IPv4, which has got 2 parts, the network portion and the host portion. Okay, again, the video here which you can watch. Okay, so from there, we'll move on. We have been moving really slowly. What did I do? Okay, so we'll move on to module 7. Maybe we have been moving slowly because, I've been trying to clarify each and every point. So this is connectivity verification. Connectivity verification. Okay. We'll start with ICMP protocol. Okay. So this protocol, it is used, to discover some errors, that we have on the network. Okay. So we have ICMP version 4 and ICMP version 6, of course, okay? So you can see that the ICMP messages, they are used for 1, host confirmation, destination or service unreachable, time exceeded, or maybe there is a route redirection, okay? So this is the first use confirm the host. What do we use? You know, I have H1 here and H2. If I want to verify whether they are connected, it means I need to go to the command prompt of H1 and type in ping. I'm pinging the address, this address of H2. Okay. So this is how we use ICMP. So what is going to be sent is an echo request, and we're going to receive an echo reply. Okay. And then it's also used for destination or services unreachable. And we have different types of messages. That is, if the code in the message is 0, it means that the network is unreachable. If it's 1, it means that the host is unreachable. If it's 2, it means that the protocol is unreachable. If it's 3, it means that the port is unreachable. Okay. We can also use it for time exceeded. Okay. So time exceeded message is used by a router to indicate that a packet cannot be forwarded because the TTL field of the packet was what? Was reduced to 0. Remember what I told you earlier. Okay. Now, for ICMP version 6, we have got different types of messages here. We have router solicitation and router advertisement messages. Okay. So when we are dealing with routers only, we're dealing with router solicitation and router advertisements. But when we're dealing with other devices, we're dealing with neighbor solicitation messages and neighbor advertisement messages. Okay. So this is the router solicitation message that is between the router and the device. So the thing is, between the router and the device is router solicitation. Okay. So of course, what we are seeing here is a situation where the router can be able to send a router solicitation message. Okay. So the RIA messages are sent by the router to provide addressing information to the host using Slack. Okay. Then the router will send the RIA message periodically or in response to the router solicitation message. Okay. A host using Slack will set its default gateway to the link local address of the router that send the RIA. Okay. And then also address resolution. Okay. So we have address resolution messages between the IPv6 devices. So the NA messages are sent when a device knows the IP address of a device but does not know its MAC address. So this is just an equivalent to what is known as an ERP. Okay. In an ERP, this is a situation where in a local area network, okay, as I told you, in a local area network, devices use MAC addresses. So it might be one device wants to communicate with the other, but it doesn't have its MAC address. So that device is going to send an ERP broadcast to all the devices. So the devices, they open the message and compare the IP address with their IP address. If it doesn't match, they drop it. But if the IP which is in the message with their IP matches, then they're going to reply with their MAC address. That's how that device is going to know the MAC address of the other device. Okay. All right. And then we have also DAD, which is used, to make sure that the IP addresses that have been given or assigned to a device is unique. Okay. In fact, it just works on the same principle here. That is, if a device has been given an IP address, okay, that device is going to send a broadcast, and in that broadcast, it is going to include its newly assigned IP address. okay? That message will go to all the devices, and the devices, they open the message and compare the IP address in the message with their IP address. If it doesn't match, they drop. But if it does match, they will reply. And then when the receiver receives that message, then it's going to know that the IP address has been given, it is being used by someone. Then it will drop that IP address, and then it will request for the other IP address. That is how DAD works. So you can see, very, very important to know the concepts, okay? Very, very important, how things work, okay? Ping and traceroute utilities, okay? So there's a video here, but I've talked about a ping already. So we have got ping, which we use to test connectivity between two devices, okay? For example, if you want to find out whether your newly bought laptop can connect to the internet, then you ping 127.0.0.1. And if you're going to receive the reply, that means that your laptop is going to connect to the internet, okay? That's how we use ping, okay? Or if you want to test connectivity between two devices, you also use a ping. So you can see here, make sure what to take notice. This is for, this is the loopback address for IPv4. And this is the loopback address for IPv6. As you can see, :1. Very, very important to know these. Okay. All right. So sometimes you find that the network in your organization has gone down. Okay, it has gone down. How do you know that the problem is not within your organization? What you need to do is to ping the default gateway. That is, you ping the router of your organization. If you are able to ping the router of the organization, it means that the problem of the internet is beyond your organization, okay? That's how it works, okay? All right. Okay, so that's how about ping. Now, traceroute. Traceroute is used when you want to know how the packet has moved, okay, or how many routers the packet has passed. We use traceroute for that, okay. All right, so this is the ICMP packet format, and as you can see also, it has different components that you really must know. And these are the codes. So if the code in the message is 0, it means that is an echo reply. If it is 3, it means destination unreachable. If the message code is 5, that is a redirection. If it is 8, it means that is an echo request. 11 means that time has been exceeded, okay? So that is on connectivity verification. Make sure you know these utilities, ping and traceroute, okay? Ping and traceroute. Okay. Okay. All right. Okay, do we have any questions so far on what we have looked at? And I think we are going to end here. And as you can, I see, at least I'm feeling much better. I'm gaining the momentum now. So this time around, we have to do it. Okay, we have to work hard you complete the course, and then you go further and get certifications, okay? So when you're getting certifications, I mean, and then if your qualifications are going up, okay, and you're going to be on demand, and you're going to be able to work anywhere, okay? All right, so I'll see you next week because, I still have that other training, okay? I'll see you next week, Monday and Tuesday, okay? Tomorrow, Wednesday and Thursday, I have Huawei security, okay? So I'll meet you next week. I really appreciate that you have attended. Thank you very much. Good night.
Sir.
Yes.
Sir.
Yes.
Just a reminder, you told me that you're going to show me how to type answers on the the lab.
Good. Okay, fine. Okay. Now, okay, let me just look for the student lab. These are for instructor. Okay, where can I find them in my old? Okay. So let me just use the odd ones for students. Okay. Okay, so like the first lab, isn't it? Okay, on the first lab, have you seen here? Are you able to see? So,
yes, sir.
So you do it, you can just type here. Okay, you can type like that.
Okay.
Once you have done that, I mean, you can do it nicely. It doesn't matter. I mean, you don't have to underline them. No, you can just type them like that. Like this. Once you have done that, then you can be able to save. Okay. Let me just give you another example. Okay. This one again. You just have to click here and you type. I get what I'm saying. It's just way.
Yes, sir.
Yeah, and then here, again, the same thing. Okay, once you are done, you save the lab. Okay, you save the lab, you save the lab. Now, when you are done with all these labs, which are in, which are in module 1, you email them to me. Did I give out my email?
You did, sir.
Yeah, so it is in the labs where you're going to get the skills from. I've seen only a few have submitted. And also continue writing the chapter exams. Okay, and you can be ahead of me. It doesn't matter. Okay, all right. Good night. Thank you very much.